Hey guys, Jason here. Welcome to Timberfalls, home for CNC creators like you. Today we're diving into a quick start guide for Carveco Maker. If you're just starting out with your CNC, this video will help you jump right in and create your first project with ease. So let's get started and make bit happen. When you first open Maker for the first time, it will start you on this help tab. If you'd like a more in-depth tutorial, I have the Ultimate Beginner's Guide, which is a 4-part series that breaks down every single thing in the software. I'll link that in the description below and tag it above at the top. We're going to start a new model. Now this box is the setup for your material or what you're going to be cutting out on your CNC machine. If you have a piece of wood, and let's just say it's 8 by 12. You can put in the 8 by 12 and this will show you the size and direction that your material needs to be laid out. If you want to lay it out the other direction, you simply just change the width and the height, depending on how you want to lay out your material. These little circles in the corner, this is for your reference place on your CNC machine, and this matches where you probe your material. So if you probe your material from the bottom left corner, as most CNC machines do, then you would have this bottom left corner checked. If you want to reference the center of your material, all you have to do is click these little circles and it'll jump around to a different reference point. Most probe blocks work off of the bottom left corner, and this helps the software and your material be in alignment. You can work in millimeters or inches depending on what part of the world you're in. And we have a resolution bar, and this is just how many pixels or points that is going to be used in your project. You pretty much can leave this at max resolution. Once we open up and start our project, we're going to be presented with our project window. Now this is the basic layout that you will be designing from. There's 3 basic stages in making a CNC project. The first one is designing the project. The second one is creating the tool paths to cut that project out. And the third step is to go to the CNC machine and run those tool paths to cut out the project. Now the first step is our design phase. Now, before we get started, I want to show you a couple of features that we're going to turn on that are going to help us in our design phase. If we go up to this View tab, we can click on this Show Cursor Information. And what this will do is this will give us a little box that will show us wherever our cursor is. And this will help us give information in real time about where our pointer is located. We also can turn on a grid that can help us line things out. Now, it's a little tiny dots. It may be kind of hard to see on my computer, but it creates this little grid that helps you draw your designs easier. We also have a ruler, and this will turn on the rulers on both the X and Y axis. And this can help you when you're trying to measure your design out or trying to figure out where on this piece of material that your design is going to be. We also have the origin point, and this just shows us where we selected our origin at the beginning. So now that we have those turned on, we're ready to create our design. Now, before we get started, I just wanted to go over the layout of Carveco Maker. Now, all of the functions that are in these tabs, some of them have shortcuts that are located on the bars around the sides. So all of these functions that are located at the top and the right can also be found in these tabs above. They just put some of the functions down here for easier use. On the left hand side, we have all of our vector tools. A vector is a line that has a direction. It has a start point and a stop point. And in CNC, that's how the CNC machine gets its instructions on which way to go when you're using a vector drawing. We have all kinds of vector drawing tools on this side. These tools down here are ways to cut and manipulate the vectors. We have a node editor. Nodes are the connection points between the vector lines. So when 2 vectors connect, they connect at a node. These nodes can be moved around, and that's what this button at the top, the node editor, is. And then we also have a transform tool that allows us to resize our project. At the top, we have 2 different libraries. You have a vector library, which is just designs that are made up of lines. Now, when you open this up for the first time, you won't find all of these different vectors, but you can download them by clicking the Get More Vectors artwork. That will allow you to download this library that has all of these vectors pre-installed. We also have a 3D relief library. Now the difference between a 3D relief and a vector is a 3D relief is an object with all of the 3 dimensions that you would cut. So the X, Y, and Z axis. Now these models are shapes that will fit inside of your material. These tools at the top, the Vector Doctor and the Bitmap to Vector tool. The Bitmap to Vector tool allows you to take any kind of picture. A bitmap is another word for a picture or a photograph. You can take any picture or photograph and create a vector tracing using the Bitmap to Vector tool. The Vector Doctor can help you solve any kind of vector issues. And this is when you run into vectors that run into each other or that may be opened instead of closed. This tool helps you fix those vectors and solve problems in your designs. We have our block and rotate and paste along a curve tools, and this allows you to duplicate any of your vector drawings. This next section is some of the tool paths that you would use to cut the projects out. Now over here on the right hand side we have this projects window, and the projects window has all of our layers, vector layers, and bitmap layers. Now layers, you can have multiple layers of vectors, and so you can organize your design based on layers. So you could put one design on one layer, another design on another layer, work on those separately, and then combine them at a later time. You can turn your layer vectors on and off with these light bulbs. These light bulbs are visibility light bulbs that allow you to see, turn on, and turn off all these different layers. If we click on the toolpaths button or tab here, this will bring up all of our toolpath operations, all of the 2D toolpaths, as well as the 3D toolpaths. If you want to know what all of these functions do in depth, you can check that out in our Ultimate Beginner's Guide as I go over every one of these functions. For our quick start guide, we're just going to show you the basics of how to import a vector design that you may have purchased online and cut that out. To do this, we're just going to go up to our Vector tab, and we're going to click Import. And this is going to bring up our import window. Now we just need to go to our vector that we want to import. And once we import that vector, it's going to open up with this transform tool. This will allow you to resize this vector. You can unlock the aspect ratio and change each edge individually simply by unclicking the lock aspect ratio button. If you right click the vectors, you get these options menu, and one of them down here is to align the vector centered in the model. It's also the shortcut F9, and that centers that in our material. Now we have our vector imported, and we're ready to cut it out. Now there's a couple of options on how you could carve this. A very popular way is to do a V-carving. And so to do a V-carving, we want to select all of the vectors that we plan to carve. If we go over here to our 2D toolpaths, because this is a vector artwork, this is 2D or two-dimensional. And in our 2D toolpaths, I'm going to go over these really quickly. We have our profile toolpath. A profile toolpath basically follows a line or a vector, and it just goes around. And this is the one that you would use to cut it out. So if I wanted to go around the outside of this and cut this out, I would be using a profile toolpath. The other toolpaths that you'll use a lot will be the area clearance toolpath. This is also called the pocketing toolpath. So this is a way to create an area clearance or a pocket in your design. So if you wanted to pocket these letters out, you would use the area clearance or pocket toolpath. We also have our V-bit or V-carving toolpath. This is the one that we will use for a V-bit carving. When I select my toolpath that I want to use, the first option it gives us is our selected vectors. So we're using the selected vectors that we want to carve, and we have our cutting depth. Now the start depth is going to be the top of the material, so we're going to leave that at 0. Now I have the option to limit how deep the carving is going to be. If we pick a carving tool, this is when you're going to pick what bit you're going to use. It's going to open up this tool database. Now you may not have all of these different databases. You can go to the different manufacturers and download their databases from them. I know Amana Tools, Speed Tools, Cadence Manufacturing, the Jenny Bits, they have their own tool databases, and you can download those, and it will have all of the bits that they sell, and you won't have to enter all the bit information. So you select the bit, and for this, we want to get a V bit. So I would use let's just try this 60-degree groovy Jenny bit. Now, once I have my bit selected, if this next box down here, if I click this refresh button, it will tell me how deep this 60-degree V bit needs to go to be able to carve all of this in one pass. And it says that it's going to go 0.44 deep. So if I carve this and let the bit do it in one pass, it'll go all the way down to 0.44. Now let's say that we only wanted it to cut down 1/4 of an inch. So we could limit that depth of how deep the carve is to a maximum depth of 1/4 inch. Now, because we are not allowing the V-bit to do the carving in one pass, it's going to go down and go back and forth until it carves the area inside these larger areas. So in order to speed things up and to make those areas flat, we would use a roughing tool. Now the roughing tool is going to go in and cut the material that is in between where the V-bit needs to go. Generally, you only need to use a roughing tool when you are limiting the max depth. So when you limit the max depth, you need to use a roughing tool. If you're not limiting the max depth and you're just going to let this 60-degree V-bit cut all the way down to the 0.44 inches, then you don't really need the roughing tool. In this example, we're going to limit it at 1/4 inch, and I'm going to add a roughing tool. Now generally, I like to use compression bits. The compression bit gives a smooth bottom surface, and it also has a very nice top edge. And so original Jenny compression bit is one of my go-to bits for this type of cut. Now we have this box that gives us a safe Z and a home Z. The safe Z is how far the router is going to retract in between moves during the cut. Now normally you want this safe Z high enough to get over the top of any clamps that you may have on top of your material. So if you have a clamp that's sticking up 1/4 inch over the top of your material, you need to put in at least enough distance to clear the top of that. Now, if you do not have any clamps on top of the material, or the tool path is not going to run into any clamps, you actually want this very small, because the more distance it has to retract in between every move, the longer it's going to take to cut it out. Now, the home Z over here is where the router is going to start and stop the project. So when the project first starts, the router is going to move to this height, move over, and then start making the cut. And then when it finishes the project, it's going to raise up to this height. Now, it's a good idea to have 1.5 inches or 2 inches of home Z so that you have enough room to get in there and change bits without actually having to move the router. So that's the advantage of having a home Z. Now at the bottom we have of their toolpath, we have the define material. So in the very beginning of the project, we only defined how large our piece of wood was, but we never defined how thick it was. So that is where this comes in, is the thickness of our material. So our material thickness is in this box, and we would want to have a material that was thick enough to cut this out. Now we're limiting it at 1/4 inch. So let's just say that our material was 1/2 inch thick. Now the 1/2 inch brought up this window. This material Z0 is where you're referencing on the material. So if you probed the top of the material, then you're referencing the top of the material. There is a situation where you can probe the wasteboard and you would select this button, and then the machine will automatically know the offset to the top of the material. Since we probed from the top of the material, we're going to click this button to indicate that we probed from the top. Now, the model position and material, this is where inside of that 1/2 inch thick piece of wood we're going to start cutting our carving. Now, since we wanted this to start at the top of our material, we're going to leave this at the top. Okay, and then once we have all of our settings put in, we're ready to calculate our toolpath. When we click this button, it's going to go in and calculate all of the different toolpathing and where that bit is going to cut. You can turn these toolpaths on and off by clicking the light bulbs. Now, if we want to see or simulate to see what this is going to look like, we have 2 simulation buttons. We have a slow control bar simulation. If we click this, and you can see this represents our bit down here, we can hit play and it will show us how our carving is being carved. You can speed this up by clicking the speed along button, and there we have our first carved piece. Now, I wanted you to notice at the bottom of these letterings how it missed this piece of wood in the middle. The reason that it missed that is because the 1/4 inch bit was too large to fit down in the bottom of this groove. And so it just skipped it. And so the V bit made 2 carvings to try and cut this out, or to cut this letter, but that 1/4 inch bit could not fit. If we click on our simulation and we go to this trash box, we're going to delete that simulation. And we need our vectors turned back on. Now, this bar on the right hand side is the visibility bar. The button at the top always recenters your project. You can use the mouse wheel to zoom in and out. If you hold the mouse wheel down, you can turn your project left and right. If you just left click, you get the selection box. If you hold both mouse buttons down, you can move or pinch the material around. If you ever get off the screen and you want to quickly recenter the project, this button at the top recenters the project. Coming down, we have other visibilities. The other important one is the vector visibility. This turns your vectors on and off. This is another one that's really important and you use a lot. And the last one down here is our display material. Anytime you see a little white check mark in the corner of these boxes, means that if you left click and hold it down, there are more options behind each of these buttons. So every one of these buttons that has a little white corner means that it has more options underneath it. Same thing over here in your drawing options. The ones with the little white check marks means that it has more options hidden underneath that. Now, to change that 1/4 inch compression bit back to a smaller bit, we would just go back to select a new bit, and we could try a 1/8 compression bit instead of that 1/4 inch compression bit. And all we need to do is press recalculate. Now it says we did not select the vectors, so let's select our vectors and we press calculate and we click on the toolpaths. If we, instead of the simulation control bar, this simulate toolpath on the right is called the fast simulate, and this will do the entire toolpath all at once. And you can see that that 1/8 inch bit was able to fit into these areas and carve a little bit better. There's still some spots that it was not able to get. If you wanted to fix that, you could either use a smaller bit. Let's delete our simulation, turn our vectors back on. We turn off the visibility for the V-bit carving. The other option you could do is to change the size of these letters. We know that it doesn't fit in the bottom of the lettering. So if you click on the letter itself and you go to the transform toolpath, now we want to do them all at the same time. So click on the transform toolpath. This would allow you to change the size of just this USMC. And so you could blow it up a bit larger. And then you can also use on your keypad, the arrow keys to move this around. So a really quick way to center this is to press F9, which we learned earlier, that'll put it right in the middle. And then we just use our down arrow key to bring it down. Since it's centered, it stays tracked in the center. And then we can just bring it down to where we want it, like this. And then if we're ready, we can select all of these again, and we can go double click back into our VBit carving. We have all of our settings are saved. So all we have to do is calculate again, and we can simulate that toolpath again. And you can see that we almost got all of the lettering. So you could go back and make that larger and get that all in there. And that's a quick start for a 2D. And that's how you do a vector or carve a quick 2D vector. Now let's say that you also wanted to cut this out of this piece of wood. We go back, click on our toolpaths, and we can create a toolpath to cut this out. Now we need a vector in order to have something to follow. So if we use our rectangle or square, we can put in how big our rectangle or square needs to be if you wanted an exact size. Or you can just draw one out and then resize it. So let's make this 9 by 7 1/4. And when we press create, we always want to close these boxes because it'll allow you to keep creating more and more squares. And now that we have a vector to follow, we can use our profile toolpath to cut it out. The profile toolpath has a couple of options. We can have the bit go on the outside of this line, the inside of this line, or follow right along it. Generally, we use the outside vector. The allowance is if you want to create a buffer or a distance further away from this line to start your cutting. If we wanted to have sharp corners, we would click the sharp corners. If you don't click this, when the bit gets to the corner, it's just going to round them off. But by clicking the sharp corners, the bit actually goes past the corner and then comes back and comes this way to get this other corner and creates a sharp corner. We have our start and finish depth. Since our material we had set up in the other toolpath, it carries over to this toolpath. And so it knows in order to cut this out that we need to go 1/2 inch because that's how thick we had set our material. Now we have to pick a tool, a bit, to profile this out. Most of the time when you're doing profile paths, you just want to use like a 1/4 inch down cut bit. Generally, when we do our profile passes, we also want to use ramping. Ramping allows the bit to come into the wood at an angle rather than coming in straight down. There's a lot less stress on the bit, and this will keep you from having dwell marks on the sides of your projects when you cut them out. If you want to add bridges or tabs are small pieces of material that's going to be left over to hold the project in. Now, you can set this up at a constant rate, a constant number. I generally put 1 tab per side to hold something in. You have to tell it how big these tabs are going to be. I always use whatever size bit that I'm using. So if it's a 1/4 inch bit, then I'll make my tabs a 1/4 inch long and a 1/4 inch thick. You have 3D and 2D bridges. 3D bridges are faster, but 2D bridges are stronger. All you need to do is press add, and that gives us our bridges along our profile paths. Then all we need to do is calculate that tool path. You can see that it simulated cutting that out, but leaving those tabs in place. If we simulate the VBit carving as well, then there's our sign. So I wanted to show you on this VBit carving, if you don't limit that toolpath and you get rid of the roughing bit, it will carve those letters in one pass, and generally that always looks better, and that'll allow you to get that deeper look. So I just wanted to show that. Guys, now that we have those toolpaths set and we're happy with our finished product, our final step is going to be to send this to the machine and cut it out. To do this, we're just going to click our Save Toolpaths button, and this is going to bring up all of our toolpaths that we have for this carving. Now, it's important to know that when we bring up the Save Toolpath button, it's going to give us each one of our carving tools. We have a 1/8 mini Jenny compression bit the 60-degree V bit and the 1/4-inch down cut bit. This top directory that it's going to go into, and then the file name is the actual name of the file that you're going to be cutting out. So I'd want to rename this to USMC Bulldog. And then below that is the machine file format. This is going to be for the type of machine that you have. I'm using the original Onefinity, and so mine uses the Onefinity millimeter NGC post processor. You will need to change this post processor for your machine. If you're not sure which one that you should use, usually that information is on the machine's website or can be found in their forums. If your machine does not have an automatic tool changer, you'll need to save each one of these tool paths as a separate file in order to run them individually. To do that, we just click the Save Toolpaths to Separate Files button. And I also like to click this Append Toolpath Details to the file names. What this is going to do, it's going to add each one of their bit names to the file. We're just going to click Save, and it's going to have saved all of our toolpaths. These toolpaths will now be the 3 different toolpaths that I need to go and carve this out. So I would save these 3 files to a thumb drive. I would plug that thumb drive into my machine and then run each of these toolpaths separately. Lastly, with the profile pass, cutting it out. On your machine, you only need to set the X and Y for the project, and then each one of these bits, you have to reset the Z 0 for the top of the material between each bit. So after you run the 1/8 inch compression bit, you would put in the V bit and then reprobe 0 to the top of your material. Same thing with the profile pass. After you finish the V bit carving, you would put in the 1/4 inch down shear bit and then reprobe Z 0 to cut it out from the top of your material. And when you run all 3 of those tool paths, your project should look exactly like our simulation. This is a very simple project to create. Guys, if you found this tutorial helpful, give us a thumbs up. Consider subscribing to the channel and share this with someone. I'd like to give a big thanks to all of our Timberfalls Elite members. You guys keep the bit spinning, and we really appreciate your support. If you're interested in becoming a Timberfalls Elite, check out the link below or our website at timberfalls.us. Thanks, guys.